In section 1.2 of chapter 1, which begins on page 8 of your textbook, we're going to look at the following learning objectives. So we're going to define variables, independent variables, dependent variables, and we're going to identify them in an experiment. We're going to define control in terms of an experimental method and describe the features of a controlled experiment. And then finally, we're going to list the strategies for minimizing bias when designing experiments. So to start off with, just a quick reminder, remember in the first section we established that the scientific method has 4 steps. The first step was to make an observation, which is where you were making a statement about what you've noticed, or statements about what you've noticed. And then second, we use that to form our hypothesis, which is our proposed explanation for our observations. So then picking up in section 2, we're going to look at the third step of the scientific method, which is the actual experiment. So with this experiment, we're going to collect data or information. We're testing our hypothesis in hopes to see that it is supported. So an example here was scientists will measure the effects of vitamin C on cold prevention, because remember we had established before that our hypothesis was vitamin C supplements would decrease the number of colds. So in the experiment here we would actually test to see if that were true or supported or not. So one of the terms to consider here is a variable. So variables by definition are factors that may change, and we know that in an experiment we have 2 types of variables. You have independent variables and dependent variables. The independent variable is the thing that is manipulated by the researcher. The dependent variable would be those things not changed by the researcher but are actually measured. So if our experiment is measuring the effect of vitamin C on cold prevention, then the independent variable would be the intake of vitamin C, because that's the thing that you're changing. So more than likely you probably would have 2 groups. Group A would receive the vitamin C, Group B would not receive vitamin C. So the thing that we have manipulated is the intake of vitamin C. So that would be our independent variable. It's the thing that we're changing, the thing that we're testing. The dependent variable would then be something that I did not change as the researcher, but something that changes during the experiment, and typically it's what we call the observable effects that actually happen and we can measure. So again, the whole purpose of this test was to see if vitamin C could prevent colds. So the independent variable is we would change the vitamin C intake. The dependent variable was their susceptibility to catching a cold, so whether or not they caught a cold. So the key thing to remember here is that the dependent variables are dependent upon the independent variable. They're the things that are observed once you make those changes. Now, a controlled experiment, it's called a controlled experiment because there are several things that you actually control. First off, you test the effect of a single independent variable. It's very important here that you don't change multiple things. See, for example, in our test, we're wanting to see how vitamin C affects colds. So the only independent variable we're going to have is the amount of vitamin C that is taken in. We would not also want to dress some warmly and some not, give some echinacea tea and some not, make some sleep longer and some not, because what you'd end up having is too many independent variables. So at the end of the experiment, you would not be able to determine which one actually prevented colds. So you only want to have one independent variable at a time. The second thing is you want to make sure that you limit possible alternate hypotheses. So you want to make sure that at the end of your experiment, that if your hypothesis is supported, it is supported in such a way that you're not starting to think, well, there may have been other reasons why I got this result. Differences in results should be due to treatment of the independent variable. And so then at the bottom of the screen, a vocabulary term is a control or a control group. So a control or a control group is going to be something that stays the same. The control group is the group that does not receive the independent variable. A control in an experiment is something that remains the same. So typically, if we did this experiment with the vitamin C, so our 2 groups would be made of people that are the same age, or around the same age range. And so everything else would be maintained as the same. They would both get the same amount of sleep every day. They would both dress with the same warmth. They would both consume the same amounts of food. The only thing that would be different would be that one group would receive vitamin C and the other would not. So controls or control groups are going to be those things that stay the same. A lot of cases they're called the norm group. And the reason that you have this is because you have to have something to compare to. So you'd want to keep a group that does not receive the vitamin C because you would need to know if vitamin C was better than not consuming it. So this control group gives us something to compare against. So let's look at an example here. Imagine that you head up a research expedition to a remote location. You have a medical computer, some medicines, but no doctor with you. 3 members of the research team come down with different illnesses, and you must decide how to treat them. The medical computer diagnoses their illnesses and finds out some basic data on treatment options. Luckily, some of the drugs that have been used to treat their conditions in the past are available. So your computer finds out the following. Disease A, if treated with drug A, has a survival rate of 23%. Disease B, treated with drug B, has a survival rate of 56%. Disease C, treated with drug C, has a survival rate of 89%. So how would you treat your assistants? Well, some of you very quickly would say, okay, well, if they've got disease C, I'm very quickly also going to give them drug C because it's got a survival rate of 89%. And you might say, okay, those with the disease B, I also might go ahead and give drug B because the survival rate is better than half, right, 56%. But some of you would also go on to say, okay, disease A, I would probably not give you drug A because you're only going to have a survival rate of 23%, right? What data here is missing? When you look at the information that they give you, what's the one thing they don't tell you? They tell you what the drug survival rate is. They tell you what happens when you give them the drug, but they don't give you the control. So what if I gave you this information? Disease A, if left untreated, has a survival rate of 10%. Now go back. If treated, the survival rate is 23%. Now, at first glance, we would say 23% is not enough to give them the drug. But look what happens if they don't get treated. Only 10% of them survive. So that would probably change how you actually would treat them. Look at disease B. Disease B left untreated has a survival rate of 54%. So it's about the same whether you treat it or you don't. Disease C, if untreated, has a survival rate of 95%. So this data tells us if you don't treat it, 95% of them are going to survive. However, if you treat it, only 89% of them are going to survive. So does this missing information change how you would actually respond to this situation? Absolutely. So controls are important because they tell us what would happen if they don't receive the change or they don't receive that independent variable. Now, moving towards the end of section 1.2, we talk about some other things associated with controlled experiments. For example, the steps. First, it's important that you do random assignment to the control or the experimental group. Meaning if you have 2 groups, you just randomly select one to receive the independent variable and the other to not. Number 2, identical participation for the groups except for the testing treatment. So everything needs to be controlled. Like I said, you want to have about the same types of participants. You want to then receive the same amount of sleep. Everything else about them should be the same except for one receives vitamin C and the other does not. So let's look at another example, this one involving echinacea tea. So let's say that upon some observations you make, you form the hypothesis that drinking echinacea tea relieves cold symptoms. So the first thing that you would do is you would set aside your 2 groups. You would name one of them as the experimental group and the other as the control group. The experimental group, you're going to give them echinacea tea and they're going to drink it 5 to 6 times a day. The control group is going to drink tea as well, but their tea is not going to be echinacea tea. We would call this a placebo. See, in actual medical studies, they give both groups a pill, one of which is the actual drug, the other is just a sugar pill or a placebo. The reason they do that is because they don't want the groups themselves to know which pill they're actually receiving. They don't want them to know that they've not been given the drug or that they have, so that you don't end up thinking that you're having certain symptoms. So in this case, we would give both groups tea. The only difference is one would be echinacea tea, the other would just be a placebo. So what would be the independent variable and the dependent variable? Well, the independent variable would be the actual tea, right? They're drinking tea 5 to 6 times a day, but theirs is echinacea tea, the other is not. And then the dependent variable would be whether or not the cold symptoms went away, something that we could measure. So then from there, our results, they say the experimental group that actually received the echinacea tea, they felt that it was 33% more effective. So that was our result, and so from there we would form our conclusion, which says whether we accept or reject our hypothesis. So for example, drinking echinacea tea was 33% more effective at relieving cold symptoms in an experimental group. So our conclusion says that our hypothesis was supported. Now, let's put this into practice, look at a couple of examples, and we'll be finished with Chapter 1. As a lab technician for Blabbit Labs, your research division has stumbled across a new drug that you believe will cure male pattern baldness. You design an experiment with 500 men who've been diagnosed with male pattern baldness. They're divided into two groups. Group A men will receive the drug. Group B men will receive a placebo, drug that's known not to affect baldness. The men will receive the drug or placebo once a day, and all of the men will have the number of hairs per square inch of their scalp measured in a clinic once per week. So based on that information, take a few moments to determine the experimental group, the control group, the independent variable, and the dependent variable. We will go over these answers in class. So here's your experiment again. If you wanted to read through this, you can pause now to determine those two variables and those two groups. And again, we'll go over these answers in class. And then one final experiment just to let you practice this. Nico Tinbergen was a Swedish ethologist, or an animal behaviorist. He was famous for studying animals in their native habitats. One of his classic experiments involved a bird called the black-headed gull. Black-headed gulls build nests of twigs on the ground, and they lay light brown eggs that are covered with dark brown spots. However, the inside of the egg is white in color. Tinbergen noticed that adult gulls pick the eggshells shortly after a chick is hatched and fly them to a location far from the nest where they are left. Since this behavior required expending energy and time that could have been spent feeding and protecting the chicks, Tinbergen wanted to know why the birds did this. So, take a moment to determine what his observation was. And then based on that observation, he then formed this hypothesis. The white interior of the shell is not camouflaged and attracts predators to the nest. Therefore, the gulls remove the shells to decrease predation or predators. So then based on that hypothesis, this was the test that he ran. Tinbergen and his co-workers collected gull eggs. They painted 69 of them white. 68 of them left their natural color. Statistically, these numbers are close enough that they are considered to be equal. The researchers then scattered the eggs next to the gull breeding area and observed from a nearby blind. Predation rates are recorded for white versus natural colored eggs. So the white eggs, there were 69 of them. 43 of those were taken by predators. For the natural color eggs, there were 68 of them. Only 13 of those were taken by the predators. So given that information, take a moment to determine the experimental group, the control group, the independent variable, the dependent variable, and to determine if Tinbergen's hypothesis was supported. And we'll go over these answers in class as well. So finally, very end of Chapter 1, the last objective mentions minimizing bias. See, bias influences our results, and in a true scientific experiment, we want to make sure that there is no opinion. Science has to be objective, meaning it can only involve facts, not opinions. So in order to minimize bias and minimize my influence on the results, one of the things that's used are what we call blind studies. Blind studies, you limit participant knowledge. So the participant does not know. They don't know if they're receiving the drug or if they're receiving the placebo. So they can't sway or influence the results. Then we also use what are known as double-blind studies that says not only does the participant not know which group is which, but the researcher themselves also does not know which group is which. Again, trying to cut down on influencing the results so it actually is considered to be an objective study. And so then finally, going back to the common cold, we know that there is no cure, there is no vaccine. Best prevention, keep your hands clean, wash your hands. Through studies, we determined there's actually no effect from vitamin C, diet quality, exposure to cold temperatures, exercise. We know that vitamin C, echinacea tea, cough drops can reduce the symptoms, but not necessarily totally get rid of them. And just really quickly, these are your learning objectives that you will be tested on from Chapter 1.